This is our presentation on Lab 8 lasers. I'm Marcel Galvan, and this is
Luke Thorson.
we present today. This is an overview. We'll be covering 4 different parts. Part A is going to be laser cavity alignment. Part B will be Farabaugh spectrometer. Part C, optical spectrum analyzer. Part D, electrical spectrum analyzer.
So for part A, we did a cavity alignment on an open cavity helium neon laser. And once we got the cavity all aligned, it started lasing, and we were able to observe fundamental TEM00 modes and higher order modes. And through this cavity alignment, we had to use a alignment beam first to align both the mirror and the helium neon open cavity. And once we did that, we put the cavity on and adjusted the fine tip tilt on the mirrors to be able to get it lased. And then from there, we were able to adjust the mirrors a little more to observe modes. As you can see, we did 2 separate trials, and we were able to observe 00, 10, 01, 20, and 21 modes. And some of these applications for these higher order modes can be reducing thermal noise, which is in the LIGO gravitational wave detector, as well as optical trapping and underwater communication. And part B, we did the Fabry-Perot spectrometer, and this was comparing theoretical and experimental laser longitudinal modes of the Fabry-Perot cavity. And as you can see in the video, our first step in the process was aligning both the beam on the optical rail and centering it onto the Fabry-Perot cavity. And we used 2 different equations to theoretically measure it or actually measure it with the oscilloscope. And our results showed that the delta V mode was 621.95 megahertz for the measured using the oscilloscope. And when we just kind of estimated it using the length of the cavity, we got 612 megahertz, and that was a pretty good error percent of just 1.58. And as you can see, those are our data points.
All right, for part C, optical spectrum analyzer, we're going to speed through this. Our objective is to compare the spectral characteristics of the HE laser and the red diode laser. You can see here what we did here is at first we went through the HE laser and then the red diode laser. You can see that we compare the peaks to peaks to get the width of the band, and then we compare the actual width, not the width, the peak itself. For the peak to peak, we got 2. From the peak, we only got 1 because there's no other peak to compare for the red laser diode. And here's my results for the backing up what I have to say earlier. Pause the video if you want to take a look. Part D is electrical spectrum analyzer. Before this, we'll be talking about we're only going to be focusing on the H and E laser. And as you can see here, there's only 1 peak to focus on, which is pretty good. It's all right. And here's our results. Basically, what we did was measure the laser itself, which is about 23.5 centimeters, and then we moved on from there. And if you want to take a look, please pause the video. But we're moving on now. Thank you.